Welcome to our course, Natural Language Processing, and in this part of our course, we are going to learn more about regular expressions. So before, we talked about just the very common ways of dealing with regular expressions without using any module. And in this part of our course, we're going to identify and use the different modules that are used to process regular expressions. So first of all, the question is, when do we use regular expressions module? We use the regular expressions in some of the ways, like for example, when we have overlapping match sets, or when we have multi-threading. Also, when we have a feature complete support for Unicode, and when we have approximate regular expressions matches, and also when we have larger default max caches. So we have to use regular expression modules. In these cases, it's because the ordinary regular expressions being compiled or being set may not be enough to deal with large volume of data or language or text that we have. We have three most commonly used regular expressions modules. We have, for example, a Spacey. We also have Stanford Core NLP. We also have NLTK. So among the three, the NLTK is the most commonly used one. So Spacey is inaccurate. It's also flexible and fast, and it uses Python. For Stanford Core NLP, it's actually more accurate, but it is less flexible. It is also fast, but it depends on the Java that you have in your computer. And lastly, we have NLTK. So it is the standard used by many, if not all, NLP contests and comparisons, or also it's commonly used in the enterprise level. And it's very popular and it uses Python. What we're going to do is import regex tokenizer. So we make here a variable tokenizer which is equal to regex tokenizer. Then we have this parameter, then tokenizer.tokenize sentence. So if ever you're wondering where we get the sentence, we have actually used that here, this one. This is the sentence that we are processing in this case. So as you can see, just like the former ones that we used, we have this kind. So Jack is a different token, Sam is a different token, and also we have these different tokens. And as you can see, the period now is a different token, so it's not included in the 17 token because period here is very close to 17. Actually, there is no space, but using this regex tokenizer, then we have these different expressions or punctuations. Then period here is considered a different token. We can also use the tree bank word tokenizer. So we actually use the same process, but in this case, we add something like 17.5. Then we also have the didn't, which is a contraction of did and not. We use this one for us to be able to identify what would be the outcome and how NLTK that tokenize would be able to process this kind of sentence. Now, let's execute this and let's see what's in here. So as you can see, in the case of didn't, did becomes a different token and the contraction of not is a different token, which is actually making some sense because supposedly, of course, did is a different word and not is a different word. And notice what you have in here is that 17.5 is a one single token and the period at the end is a one different token. The point between 17.5 is not made a different token, it's not identified as a different token, but of course a part of 17.5 as a token, which is actually very much correct. So the problem we have in this result is only this one, the contraction of NT. So how should we deal or process this kind of scenario? So first of all, what we are going to do is to eliminate contraction. So how to do that? First, we need to do the mapping. So we map this contraction, didn't, to its base form, which is did not. We can actually add more constructions if we want to so that we can expand the different mappings. Then we make here a function that processes this one. So we have token is equal to text.split. So basically we split the token and then we expand the token. So the contraction that mapping dot get, so we get a token. And then for tokens, which means to say that for every word that this mapping gets would be able to map to this one, and then when it finds the same thing, then it does this in the choices. Sentence is equal sentence, so we're using the same sentence here, of course. Then we apply now the function, so expand contractions, and in the argument we call our sentence, then of course we print. So let's see what's going to be in here. So as you can see, we have Jack Sam did not graduate from the university at the age of 17.5. Now let's go to splitting the different tokens. So now we are using this sentence. Okay, so let's execute this one. So again, we are using the twee bank word tokenizer the same we used in this case. So let's see if there would be a difference. Okay, now we can see it did, then we have not in this case. So sometimes you are not just processing the very basic words, but nowadays because of social media, we have a lot of incorporations into the written text that we have. So most likely we would be getting this one, this kind. We would also be getting this kind of scenario and also this kind of scenario. And sometimes we would be getting smileys and some stuff like that. That's what we're going to process. The question is, how do we process that? So first we need to import the casual tokenize. That's also from NLTK, that tokenize that casual. Then we just get, or we call this message as the parameter of the casual tokenize. Let's execute this one. So as you can see, we have now identified or split this sentence into different tokens. But the problem here is that we have still something like this. Okay, what we want to do is that to at least minimize these forms. So we have this kind to handle this kind of situation. So we have the casual tokenize, then message, then we are going to reduce the length. So reduce len is equal to 2, then strip handles is equal to 2. And now we have this one. So we have stripped this. So it's now RT. Then we have ever. We have stripped that into just ever, having only 3 R's. Awesome is being stripped into 3 M's only, and then 3 E's only. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like machine learning essentials, deep learning mathematics, and a lot more. Here, you can always learn an upskill for free.